All right, do you think you understand elasticities like price elasticity of demand and income elasticity of demand, cross price elasticity of demand, and price elasticity of supply? Well, let's see if you do. Now, if you don't have this handout and you want it, download it. I'll include a link with the video. But here are 7 questions that if you are in Introductory Microeconomics or any higher level, everything here is basic Introductory Microeconomics, nothing really fancy. You ought to be able to answer these questions. Now on the second page, I have a few notes here just to remind you of a few things in case you need it. But if you understand elasticity, you ought to know all of these things here. And just a hint, none of the answers that we're going through rely on using the midpoint formula. These are just simple basic questions to see if you understand elasticities in economics. Now, of course, you should be able to calculate elasticities and interpret elasticities. Like for each 1% change in the cause, there will be a elasticity, percent change in effect. We're not focusing on that so much here, just some very basic fundamentals. After you've studied this, after you've thought about elasticities for a minute to get this information in your brain, we're going to have a lightning round, and then I'm going to give you about 10 seconds to think about each question. I'm going to then very quickly run through what the answers are, and then, if you need it, you can stick around while I go through explanations for each of these. Let's get started with our flash quiz. Okay, lightning round. Number 1, pretty easy. Suppose an income elasticity of demand is negative. What does that mean? Question number 2, pretty easy. Suppose you have a cross price elasticity of demand and that's negative. What does that tell you? Question number 3, sort of easy. Suppose you have a price elasticity of supply is negative. What does that tell you is going on? Question number 4, medium difficulty. Suppose the price elasticity of demand is 0.2, which we know really means negative 0.2. All price elasticities of demand are always negative. If you see one written as an absolute value, you just know that has to be negative. Suppose you need to sell. You're in a business and you need to sell 10% more product. You've got it in the warehouse and it's getting ready to go bad, for example. It's going to be worthless and you want to move this additional 10% of inventory out of your warehouse before it goes bad. How much do you need to cut your price? Take a second, jot that down, do the simple math. Okay, now that you have your answer, pause the video if you need to. Number 5, related to number 4, in this previous question, when we're lowering our price to get rid of that extra 10% of inventory, what should we do? So my question here is, should you cut your price to sell the inventory, or is there a better option you can think of? Question number 6, a little bit harder. Suppose the slope of your demand curve is minus 0.5. So suppose we had a demand curve. It doesn't have to be a straight line, but let's suppose it is roughly a straight line. So it either could be literally a straight line with something like this, P equals 1,000 minus 0.5Q, and that's your slope. Or since usually demand curves are curves, maybe we're talking about a curve. Here's price, here's quantity. And right here where we are, we see that the slope is minus 0.5, okay? So given the fact that the slope is minus 0.5, our current price is $100 and we're selling 200 units. What will happen to our total revenue if we raise our price just slightly? And question number 7, beast mode. Suppose you own 2 rare postage stamps. Here's just a picture of a rare postage stamp. It's rare because they printed the building upside down. So suppose you own 2 stamps. They're the only 2 of this kind of rare postage stamp in existence. and you go to the world's largest stamp auction, and there are hundreds of people there waiting to bid on your stamps. All of a sudden, you run up on stage and you eat one of the stamps, and everyone sees that you ate it and you chewed it up and you swallowed it. Why would you do this? What's something about elasticity that might make you want to run up there, swallow one of the stamps, and only auction off the other? So if you need to, pause the video, make sure you have good answers to these 7 questions, and in about 5 seconds I'll start and I'll tell you what the answers are very quickly. And then I'll go through and I'll give you a brief explanation after I run through all the answers. Okay, very brief answers here. Answer to question number 1. If an income elasticity of demand is negative, what does that tell you? That tells you that that good is an inferior good. Question number 2. In a cross-price elasticity of demand, if that's negative, what does that tell you? Well, that tells you that the 2 goods that you're looking at, price of one went up and the quantity of the other one went down. That tells you that they are complements. Question number 3, if the price elasticity of supply is negative, what does that tell you? Well, that tells you that you're violating the law of supply. That's telling you that as price goes up, the quantity being supplied is actually going down. And that's an unusual situation, but not unheard of. So you're violating the law of supply there. Question number 4. If the price elasticity of demand is minus 0.2 and you need to sell 10% more product because it's going to be worthless soon, how much do you need to cut your price? The answer here is you're going to have to cut your price. So the price is going to have to go down by 50% in order to sell 10% more product. Question number 5. In this previous question, what should you do? The answer is, unless there's something I'm missing here, you should just let that inventory rot. You should just throw it away. So don't actually cut your price. Don't sell the additional 10%. Number 6. The slope of your demand curve is minus 0.5. The current price is $100 and you are selling 200 units. What will happen to total revenue if you raise your price slightly? The answer here is total revenue will stay the same. Although there is a technical answer you could give where you could say total revenue will go down just a little bit. 2 ways to think about that. Question number 7, beast mode. Suppose you own 2 rare postage stamps, the only 2 in existence, and you ate one of them. Why would you do this? Well, the only thing that would make you want to do this is if you believe that the demand for these stamps is inelastic, and more particularly, you think that the elasticity coefficient in absolute value, because it's going to be negative, but you think the elasticity coefficient in absolute value is less than 0.5. So those are our answers. Now, let me give you some brief explanations as to why these are the answers. So if an income elasticity of demand is negative, that tells you that the product is an inferior good because the income elasticity of demand is the percent change in the income on the bottom, percent change in the quantity people are buying on the top. And so if we put a positive number on the bottom, say incomes are going up 10%, the only way to get a negative is if the top is negative and people are buying less, right? So maybe they're buying 5% less. That's an inferior good. Income goes up, demand goes down. People buy less. Question number 2. If a cross-price elasticity of demand is negative, what does that tell you? Well, that's complements because the formula for cross-price elasticity of demand is percent change in the price on the bottom of good A and the percent change in the quantity of the other good B on the top. So if that's negative, what that's telling us is that, say, the price of good A might be going up 10%, right? So that's the price of A. And what's happening in order to make that negative is we have to have a negative number on the top. So maybe we're buying 5% less B. And so if the price of good A is increasing, you're going to be buying less A. And if they're complements, if these two goods go together, you'll also be buying less B to go with it. So spaghetti and meatballs. If the price of spaghetti goes up, you're going to buy less spaghetti, which means you also want to buy less meatballs, which would be the other thing that's the complement here. Question number 4. The answer here is you have to lower your price by 50%. Why is that? Well, okay, let's just go look at the formula here for price elasticity of demand. Price elasticity of demand is the percent change in the quantity on the top divided by the percent change in the price on the bottom. And here we're looking at the same good, price and quantity. And I'm telling you that price elasticity of demand is minus 0.2. And I've told you also that you need to sell 10% more of your product. So plus 10% is that percent change in quantity. And we're just solving that for x. So what needs to go on the bottom in order to make this equal to minus 0.2 if we know the top is plus 10%? Well, we can just solve this for x using a little bit of algebra here, right? So multiply both sides by x, and we have minus 0.2x equals 10%. And we need to divide both sides by minus 0.2, and we get that x equals minus 50%. So the idea here is you're going to have to be cutting your price an awful lot since this good is very inelastic, not very responsive to price. So if you want to sell 10% more and people aren't very responsive to price, you're going to have to cut your price quite a bit, by 50% in this case. So the next question asks, well, what should you do in this case? Suppose the only way for you to sell 10% more is to cut your price by 50%. My answer is, don't do it. So if you have some good in your warehouse and it's going to go rotten if you don't sell it, and the only way to sell it would be to cut the price. And we're not talking about cutting the price of just that additional 10%. We're talking about assuming you have to cut the price of all of the merchandise that you're selling by 50%. Don't do it. Why not? Well, because your total revenue is going to be going way down. Let's just look at a numerical example here. Suppose to start off with, your price is $100, just to make it a nice easy number, and your quantity you're selling is 100 units. Your total revenue is $10,000, 100 times 100. Now, of course, total revenue is not everything. What you want as a business is not total revenue, but you want profit. And profit is total revenue minus costs. So total revenue minus total costs. It seems to me, the way that I've asked this question, that you already have the product. It's already paid for. In this question, I don't see any reason why your total costs would change when you sell these products. Now, there actually might be some additional costs. You might have to pay a salesman, or you might have to pay a truck to go deliver these things. But let's assume that your total costs are not going to change at all, whether you sell these things or not, just to keep this a little simpler. So, if you sell the additional 10% of product, what's going to happen? Well, we said that you're going to have to cut your price by 50%. So your price is going to go down to $50. And you're going to sell 10% more, and it's going to be about 10% more than 100. And so your total revenue is now going to be 50 times 110, which is $5,500. Now, if what you're after as a business is profit, and we're saying that your total costs aren't going to change, whether you sell this 10% extra or not, you can just throw it away, then if your total revenue is going down from $10,000 to $5,500, and your total costs aren't changing, let's suppose they're $1,000, then obviously you're being hurt here. Your profits are going to go way down if you lower your price by this drastic 50%. In order to sell an additional 10% of merchandise. Now, if you have a different take on this question, a different possible answer that makes sense that I'm missing here, please let me know. All right, question number 6. The slope of your demand curve is minus 0.5. Your current price is $100, and you are selling 200 units. What will happen to your total revenue if you raise your price slightly? So here I'm thinking about two things. I'm thinking about the total revenue test, and I'm also thinking about how you calculate an elasticity at a single point if you know the slope of a demand curve and you know the price and the quantity. So let's have a look at those two things. So the point elasticity here says that you can calculate an elasticity, and this works for supply or demand curves, as 1 over the slope of the supply or the demand curve as we graph it times the price over the quantity. In this case, we're saying that the slope was negative 0.5, so 1 over negative 0.5 times price over quantity. I said suppose that the price is $100 and suppose that you're selling 200 units. Well, 1 divided by negative a half is negative 2, and 100 divided by 200 is 1/2, simplified. And so this is saying that your elasticity, your price elasticity of demand, is -1. So that's unit elastic. It's not elastic and it's not inelastic. The total revenue test says that for price elasticity of demand, if you raise price and your total revenue goes up, you're inelastic. Your absolute value of your elasticity is less than 1. If you raise price and your total revenue goes down, it's elastic. If you lower price and total revenue goes up, it's elastic. So that means the absolute value is bigger than 1. And if you lower price and your total revenue goes down, it's inelastic. Now, another part of the total revenue test we could add here is if your price elasticity of demand is exactly unit elastic or unitary elastic. As you change price small amounts, we're saying it's not big amounts because your elasticity can change a lot as you change price drastically. But if you change your price a small amount, your total revenue should not change. Now, why is that? The idea here is that since total revenue is price times quantity, that if we have a product that's very inelastic, what that's going to allow us to do if it's inelastic, if I raise my price a lot, very inelastic product, people aren't going to respond much. They're not going to buy a lot less. So you can raise your price a lot, and maybe your quantity will go down just a tiny bit. So when you multiply those two together, the product is going to be a larger number if it's very inelastic. But if it's unit elastic means that the percent change in quantity divided by the percent change in price is equal to -1. That's telling us that the percent change in quantity and the percent change in price are the same amount. So you can raise your price, say, 10% per unit. You're going to sell 10% fewer units. When you multiply those two numbers times each other, the changes will basically, more or less, cancel each other out. Now, the one exception we might say here is, okay, well, if we're saying that our demand is a perfect straight line, that's a technicality where we could come up with a legitimately different answer. Right here in the middle of the demand curve, halfway down on the price, halfway over on the quantity intercepts here, if the elasticity is exactly equal to -1 there, it's really only equal to -1 at one place. And at that point, that is where the total revenue is maximized. So we could say, if we were dealing with a straight line demand function, if we were at that one point where the elasticity equals -1, we know everywhere up top we are elastic, and everywhere on the bottom we're inelastic. Then technically, since that one point in the middle is where total revenue is maximized, as you raise your price slightly, your total revenue will go down slightly. But technically speaking, we usually say, if you have a product whose elasticity is exactly unit elastic for price elasticity of demand, as you change price, total revenue will stay roughly the same. All right, last question, beast mode. So you're at an auction and you have 2 stamps for sale. Right before the auction, you run up and eat one of the 2 stamps. Why would you want to do this? Well, the answer is you think that demand is very inelastic. Your elasticity coefficient in absolute value would have to be less than 0.5. Now, why do I say that? Again, we're thinking about you have the stamps. your cost for the stamps, you've already paid for these stamps. So whether you eat the stamp or not, hopefully it's not poisonous, but your costs aren't going to change. So what you're trying to do here is really just maximize your total revenue, since we're assuming costs are not going to change when you do this. If you want to maximize total revenue, you have a choice. You could either say, well, I want to sell my 2 stamps, which is your quantity, times some price, or if I eat 1 stamp, I could sell 1 stamp at a different price, right? So we'll call this price 1, we'll call this price 2. And what you have to ask yourself is, which of those 2 are going to be bigger? Selling 1 stamp for the higher price or 2 stamps for the lower price? So what we're saying here is, let's suppose that if you sold 2 stamps, your guess is that you could sell these stamps for, say, $100 each. Then your total revenue would be $200 from selling these stamps. By eating one of the stamps, what you're doing is you're cutting the quantity from 2 to 1, so your quantity is going down 50%, right? That's your change in quantity. And if we were to calculate an elasticity, what kind of price elasticity of demand do we need to see in order to make this a profitable thing to eat this rare stamp? Well, it has to be the case that 1 times the new price has to be at least $200. So probably more than $200. Otherwise, why go to the trouble to eat this thing? And then everybody's going to look at you like you're crazy because you just destroyed something that was very rare. So this 1 times price 2 has to be bigger than $200. So bigger than $200. So then you're going to end up with something more than $200, right? So you'll profit by eating the stamp. So what we're saying here is, if the price goes from $100 to $200, that is a doubling of the price, or a minimum you want it to double. So that means that you expect the price to more than double, which is going to be a more than 100% change in price here for a 50% decrease in quantity. And so when we divide 50 by something that is at least 100, hopefully bigger than 100, we get this answer that the elasticity that you calculate is hopefully going to be something like negative 0.4, maybe minus 0.1 would be even better. And that way, when you eat that 1 stamp, the quantity will go down by 50%, but the price will really increase by a lot. Maybe the price would go up 10 times because this is such a rarer stamp now. So these are some good, interesting review questions we went through really quickly here. If you have any questions, or if you dispute anything I say, if you have a better idea, please let me know. I'd be happy to hear your thoughts. Or if you have other interesting elasticity questions you'd like to throw out there, please let me know that as well. This is Dr. Berkey signing off. Please practice elasticities a little bit every day, so that way you can get better and better at them. I'll talk to you later. Bye-bye.